This is SpaceTime Series 26, Episode 58, for broadcast on the 15th of May 2023. Coming up on SpaceTime, the Moon reveals its deepest secrets, a new way to remove space junk from orbit, and China's Lunar Space Station project. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Planet Earth's nearest neighbour, the Moon, has revealed its deepest secrets. A new study has provided astronomers with the most detailed view yet of the Moon's internal structure. The findings, reported in the journal Nature, suggest that Earth's lunar companion does have a solid inner core, about 258 kilometres in radius. And that solid inner core is surrounded by a liquid outer core about 362 kilometres in radius. The research by scientists from CNRS, the Côte d'Azur University, the Côte d'Azur Observatory, Sorbonne University, and the Paris Observatory also help explain the presence of iron-rich materials in the lunar crust. Scientists first identified that the Moon had a liquid outer core some 20 years ago by studying its rotation. But the small size of the lunar inner core made its identification far more difficult. Way back in 2011, scientists using seismic data originally recorded by NASA Apollo astronauts suggested that the Moon might have a solid inner core at its centre. But it's only now that its existence is being confirmed using data from orbital observations, lunar laser ranging, and computer simulation modelling. By combining all that data, scientists were able to create a likely profile for the interior of the Moon, including characteristics such as deformations created due to gravitational interactions with the Earth, the Moon's distance from the Earth, and its likely density. After running many simulation models, the authors finally found a version which most closely matches observations. It shows that the Moon has a solid inner core, roughly 15% of its total size. And it's composed of metal, with a density of approximately 7,822 kilograms per cubic metre, which is similar to that of iron. The study's authors also identified evidence supporting the hypothesis of the movement of material within the lunar mantle during the Moon's evolution. Known as active lunar mantle turnover, it involves denser material being pulled closer to the lunar core over time, in the process forcing lighter material up towards the surface. And it helps explain the presence of iron-rich elements in the Moon's crust. The findings also help explain the disappearance of the lunar magnetic field, which was originally 100 times stronger than that of the Earth's today, but is now almost completely non-existent. Overall, this work provides an important contribution to science's understanding of the history of our solar system. This is SpaceTime. Still to come. A new Australian plan to try and remove space junk from orbit, and China's plans for a space station on the Moon. All that and more still to come on SpaceTime. Right now, there are over 200 million bits of space junk orbiting the Earth. These range in size from giant spent rocket stages and disused satellites, some tens of meters wide, down to things as small as nuts and bolts, flecks of paint, and tiny bits of shrapnel from exploded spacecraft. And all of it is speeding around the planet at over 28,000 kilometres per hour. That's much faster than a speeding bullet. The problem is, as the amount of junk in space continues to build up, the likelihood of collisions becomes ever greater. And when these objects smash into operational spacecraft, they can cause a lot of damage and even total destruction. Objects as small as chips of paint have crashed into the space shuttle's windshield, leaving significant craters. Other incidents have seen space junk impact spacecraft, destroying them completely and leaving behind a cloud of debris and shrapnel. Now, under the worst-case scenario, all this could result in a cascade effect known as the Kessler syndrome. Debris from one impact hits another spacecraft, causing more debris clouds, which then hits other spacecraft, triggering even more debris clouds, and so on. Eventually, space could become too dangerous to operate in for hundreds of years at a time. Now, currently, there's a lot of talk and a lot of plans to reduce the amount of space junk orbiting around the planet, but not much of it has been put into practice. One idea involves using nets or even harpoons to capture space junk, then use space tugs to drag it down into lower altitudes where it will undergo orbital decay more quickly, entering the Earth's atmosphere and burning up. Today, space junk is regarded as such a major problem by the European Space Agency, it now requires all European spacecraft to have an end-of-service life disposal plan in order to get them out of the way when they're no longer needed. Now, a team of scientists from Australia and Japan have come up with a new way of dealing with space junk using what they're calling hunter-killer satellites powered by superheated gas. A report in the journal Science Advances says the hunter-killer spacecraft would fire a beam of hot plasma, pushing a target piece of space junk down into a lower orbit where it's slowed by atmospheric drag and burns up on re-entry. One of the proposal's authors, Professor Rod Boswell from the Australian National University, says his tests have shown that you can push plasma out of one end of a satellite in order to thrust it towards space junk, and then push it out the other end to send that space junk in the right direction. Boswell says if you can throw the gas out as a plasma, you can throw it out very quickly, therefore making better use of it and using less fuel. To test the new plasma gun concept, Boswell and colleagues developed a sophisticated experiment at Tohoku University in Japan. They say the next challenge for the team will be to work out how to guide the hunter-killer satellite towards space debris once it's been deployed into orbit. Boswell says it's easy to calculate the orbital trajectory from the ground, getting you to within a couple of kilometres of the target. But then you need to focus in on the target using the spacecraft's own radar. The so-called Shepherd system would involve a main plasma engine, which would thrust the hunter-killer spacecraft towards the space junk, and then there'd be small orbital manoeuvring system thrusters to direct it properly during more delicate manoeuvres. Boswell says work is now underway to make the system cheaper and more effective.
Commonly, if you have a thruster, you push material out of one end of it and your thruster moves in the other direction. What we've done by using a rather clever plasma technique is to produce a thruster with two ends. It squirts out the front and it squirts out the back, and we can control that. So we can do a few things with this. We can move the thruster forward, or we can move the thruster back, or we can bring the satellite containing the thruster close to a piece of space debris and have both thrusters working at the same time, so the thruster stays in the same place, but one of the thruster blows on the debris and moves it away. So if you have just a thruster blowing on the debris and moves it away, the thruster is going to move away too, because of Newton. For all actions, there's an equal and opposite reaction. So we have a thruster with an outlet in the front and an outlet in the back, and it can push space debris around in that manner. That's the basis of what we've done.
The idea is making sure there's enough fuel on that thruster to keep it working for a long, long time. Otherwise it gets really expensive if you've got to keep putting things up there.
It's pretty expensive to put things up there anyway. It's more expensive to get them down. Yes, so that's why we use electric propulsion, because normal propulsion throws things out at a certain speed, but with electric propulsion, you use charged particles in a plasma and throw it out much faster. So if you can throw it out 10 times faster, you only need to throw out 10 times less.
With these ion propulsion systems, we've seen very slow acceleration in those for satellites. In other words, they take much longer to take effect than a normal chemical engine thruster.
That's correct.
Is this still going to be a problem?
It's very same. Do you know the story of the old bull and the young bull?
Tell me about it.
Well, there's an old bull at the top of a hill, a bunch of cows down below, and then there's a whole bunch of young bulls around the old bull. And one day the farmer left the gate open, and one of the young bulls says, "Let's go down and say hello to the cows. Let's rush down and just, whoa." And the old bull said, "No, let's walk down and say hello to all of them." The game is softly, softly, catchy monkey. So if you can keep the acceleration going slowly but for a longer time, you can have a lot more control and power than just thrusting off suddenly.
You've talked about both moving them up into higher orbits and also moving them down into lower ones.
Yes.
Moving down is really the idea. You got to get them below 500 Ks so that the Earth's atmosphere will do the rest through atmospheric drag.
That's very true. That would be the primary thing for something around about 600 kilometres. If you're at 36,000 kilometres, which is where some of these very large telecommunications satellites are, you can't do that. You have to push them up, and they go into a graveyard orbit, and we're working on that as well.
I don't know if it's legally mandated, but there's an agreement that geostationary satellites should retain enough fuel to move into this graveyard orbit.
Oh, well, it's regarded as very naughty if you don't do that, and people get very cross because you only hire the slot for 5 or 10 years, and then you have to get out of it and let the new satellite come in. I mean, they're sold. The slots, which are 2 degrees wide, I think, so there's 180 of them, are given to countries around the world to own, and they are then on-sold to telecommunications companies. So the space is sold for certain times.
Where are you at now in the development of this project?
We've done a laboratory test so that we know that we actually produce thrust forward and backward with one thruster, and we're now looking around to make a small satellite where we can test it, which is what I'm doing at the moment. In fact, I'm trying to get a startup going to get some funding in to try and test this, but that's in the future.
Is it going to be like a 6-unit CubeSat or something, or something bigger or something smaller?
The CubeSat propulsion systems that we're developing now, which will be much smaller than the one we used to test in Japan with Kazunori Takahashi, that was quite large. That would have been about a 12U CubeSat. His laboratory demo, we're trying to get into about a half a U per thruster, so that'll be 2 thrusters in about 1 U, and we hope to be able to have some sort of test platform on that in halfway through next year.
And that's a ground-based test platform or something you actually put into orbit?
No, we're aiming for a CubeSat and a launch.
Okay.
It's fiendishly difficult because people sell you lots of stuff nowadays and they say it's fine for space, but you only know that when you get out there. So you have to actually do a lot of the testing and development yourself, which is why we're collaborating with a lot of people in New Zealand, which is quite exciting, Rocket Labs and New Zealand Space Agency, and also Stanford and Japan. You need to take talents and methods of developing things from lots of different people in different places to get a success. You have to get the satellite with the thruster on it, but it also has to have lots of other small micro thrusters to be able to position itself relative to the space junk. On top of that, the space junk, you know its orbit fairly accurately within X kilometres for a position. But the satellite then will have to interrogate space junk, so it'll have to have some active radar and AI on board to be able to hunt it down. So it's really a hunter-killer system. It needs to know what it's looking for.
For the ohms side of things, what sort of propulsion are you looking at for that, these micro thrusters?
For the micro thrusters, we're looking at electrothermal thrusters, where we use the radio frequency to produce a plasma, such as you get in light globes, and then that is used to heat a gas. So the gas comes out much hotter than it went in, and that's how we would use just to push the satellite around to control its position.
Okay.
Once again, the whole aim is to save propellant, as you mentioned before.
What size targets are you aiming at? I guess that depends on the size of the hunter-killer satellite you develop, doesn't it?
That's precisely the case, yes. So anything, you'd have to see it with a radar, right? So it's going to have to be in half a metre or so, I would say, and greater. Smaller than that is going to be extremely difficult to see because small objects will just refract or deflect the radar probing waves. All of these things are quite difficult when you come back to it. It's all very good to have a headline, but when you get down to the nitty-gritty, you need some bloody good engineering to make it succeed.
One of the big concerns isn't just the decent-sized pieces of space junk out there that can be tracked, but the small bits of debris, those that are a result of cascades in space, where one piece of space junk slammed into another piece of space junk. We've seen that with Iridium satellites and Russian spacecraft, and of course the Chinese did a really great job with a disused meteorological satellite they decided to blow up in space. How do you get rid of stuff like that?
I think if you're aiming for something and you have large amounts of power, then you might be able to get close-ish to hit it. Trying to do it when you're in orbit's a damn sight different, and it's actually really unusual for that to happen. And I'd say anything smaller than a pack of cards or something like that is the best solution is prayer.
And wait for it to go down by itself over tens and whatever years, depending how high it is. We've just seen a European test of a new space debris recovery system, the first of a series of tests. They're using a net initially. They're also using a harpoon, drag it into the Earth's atmosphere with them.
Yep.
That's one proposal. Here in Australia, a place in Queanbeyan have been looking at using laser beams, not just to track space junk, but also to slow them down a little bit as well. That's another alternative. How does your idea compare to those?
Well, we're thinking of mega-concentrated sarcasm and irony, actually.
Would you like to expand on that in a more scientific way?
Well, mumble. If you're going to lasso it, then that's a suicide mission. You get rid of the thing you sent up to get rid of the piece of space junk. You then have to write that off on how much it's going to cost you and how much it's going to save you. All of these things are sort of actuary. You have to work out how much people are going to pay you to be able to do that. I'd prefer to have one stick up there for a bit longer and make small changes that can be made, but stay up there.
That's Professor Rod Boswell from the Australian National University. And this is SpaceTime. Still to come, China's growing plans to build a lunar space station, and later in the science report, the COVID-19 global pandemic emergency now officially over. All that and more still to come on SpaceTime. China is proceeding with development of its new International Lunar Research Station on the Moon's South Pole. The project, which includes the participation of Russia, would see a basic facility constructed within 5 years and the full complex completed by 2040. Beijing says the space station will be built in 3 stages, with the first seeing initial modules sent up in 2028 in order to study the local lunar environment and establish resources available for utilization. Work would then continue on building additional modules for space environment exploration and scientific experiments targeting the Sun, Earth and Moon. A comprehensive satellite communications system based on the existing Magpie Bridge constellation established by Beijing would be set up to support man-moon landings and deep space exploration, venturing further afield to Mars, Venus and beyond. By 2040, the initial experimental station would have been transitioned into a practical and multifunctional scientific research station and lunar base. Beijing says its initial plans will see the Chang'e 6 lunar mission launch next year to undertake another sample return mission to the lunar far side. That would then be followed in 2026 by the Chang'e 7 mission. It'll conduct a detailed investigation of the environment and resources at the lunar South Pole. And then Chang'e 8 is scheduled for launch in 2028 to perform experiments and verification tests related to lunar resource utilization and establish a basic lunar scientific research station. And China isn't simply shooting at the Moon. Its first reusable spaceplane has just completed its second orbital mission. The highly secretive 276-day flight was launched aboard a Long March 2F rocket from the Jiuquan Satellite Launch Center back in August 2022. Beijing are refusing to comment on any aspects of the top-secret mission, and there's speculation surrounding the identity of an object deployed by the clandestine spacecraft while it was orbiting the Earth. Some have suggested it may have simply been a service module being jettisoned before re-entry. However, the fact that the deployment took place at the end of October, more than 6 months before the spacecraft's re-entry, suggests that it's far more likely to have been a small satellite. The mysterious spacecraft touched back down at Jiuquan and was quickly surrounded by technicians. The spacecraft's first orbital mission was a 2-day flight that was back in September 2020, also from Jiuquan and also aboard a Long March 2F. Beijing's been careful to hide the design of the spacecraft, which is thought to be a copy of America's Boeing X-37B Delta Wing spaceplane, which itself was based on NASA's famous space shuttle. Images of an aerodynamic scale model of what Beijing called the Shenlong spaceplane, mounted under the fuselage of a Jiang H-6 bomber, were published in 2007. However, they don't match the artist's impressions published by Beijing, which show a scaled-down copy of a space shuttle. Meanwhile, Beijing's just launched its Tianzhu cargo ship carrying fresh supplies to the Tiangong space station. The mission aboard a Long March 7 rocket was flown from the Wenchang Satellite Launch Center on Henan Island off the South China coast. The manifest included 1.7 tons of propellant, as well as fresh clothes, drinking water and food for the 3 Shenzhou 15 taikonauts now on station, as well as the 3 Shenzhou 16 crewmen who will be replacing them later this month. The Tianzhou 6 is the newest version of China's cargo ship design, capable of carrying an additional 500 kilograms of payload in its pressurized cargo segments compared to previous versions of the spacecraft. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The World Health Organization has formally declared that the COVID-19 global health emergency is over. The pandemic, which began with what the FBI suspects was a leak from China's People's Liberation Army-controlled Wuhan Institute of Virology sometime around September 2019, has killed around 16 to 18 million people, with 7 million confirmed deaths so far and 690 million confirmed cases. The World Health Organization declared the coronavirus outbreak to be a public health emergency of international concern in January 2020. That was about 6 weeks before characterizing it as a global pandemic. The organization's International Health Regulations Emergency Committee has now confirmed that the pandemic has been on a downward trend for more than a year. And this trend has allowed most countries to return to life as we knew it before COVID-19. The United States formally allowed its COVID-19 public health emergency to end on May the 11th. Meanwhile, new research has shown that bacterial lung infection, in other words pneumonia, and not the cytokine storm previously claimed, was the primary cause of fatalities associated with the COVID-19 pandemic. The findings reported in the Journal of Clinical Investigation show that nearly half of all patients with COVID-19 developed a secondary bacterial pneumonia. The discovery by scientists at Northwestern University was achieved by applying machine learning to medical record data. The study also confirmed that COVID-19 does not cause a cytokine storm, which involves the body's immune system releasing too many cytokines into the bloodstream too quickly. The study highlights the importance of preventing, looking for, and aggressively treating secondary bacterial pneumonia in critically ill patients with severe pneumonia, including those with COVID-19. Investigators found that COVID patients who were cured of their secondary pneumonia were more likely to live, while those whose pneumonia did not resolve were more likely to die. The researchers also found that mortality related to the virus itself was relatively low, but other things happening during the ICU stay, like secondary bacterial pneumonia, tended to offset that. Scientists have shown that humans inherited their noses from Neanderthals. The findings, reported in the journal Communications Biology, show that Homo sapiens inherited the genetic material that affects the shape of the nose from our hominid cousins. The research suggests that a gene which leads to a taller nose may have been a product of natural selection in ancient humans adapted to colder climates after leaving Africa. It also confirms that some degree of interbreeding between Homo sapiens and Neanderthals took place, leaving our ancestors with segments of their DNA, including, it seems, the shape of the Homo sapien face. The study relied on data from more than 6,000 volunteers across Latin America who are of either mixed European, Native American, or African ancestry. Researchers identified 33 genome regions associated with the shape of the face, 26 of which they were able to replicate in comparisons with data from other ethnicities using participants in East Asia, Europe, or Africa. In one genome region known as ATF3, scientists found that many people in their study with Native American ancestry, as well as others with East Asian ancestry, had genetic material in this gene that was inherited from the Neanderthal, contributing to increased nasal height. They also found that this gene region had signs of natural selection, suggesting that it conferred an advantage to those who were carrying that genetic material. The president of Mexico has posted a picture of what he claims to be a mythical Mayan creature called an alaxe sitting in a tree and watching railroad workers laying new track. The photo, which was taken at night, shows a tree with a branch forming what looks like a halo of hair and what may be stars forming what look like eyes. Tim Mindham from Australian Skeptics says the ancient Mayans regarded the Luxae as mischievous woodland spirits.
President Obrador has a bit of a tendency to believe in sort of some strange things. And he said that the photo that he was shown, which was a few days old at the time, he said it looks like, and I don't know how to pronounce this correctly in Spanish, but a luxe, A-L-U-X-E, which is a mischievous woodland spirit in Mayan folklore. It's a dark shape of some sort on a dark night.
It's an owl in a tree.
It might be an owl, or it might be a little sort of creature that runs around and sort of, I don't know exactly what it does to be mischievous, obviously photo bombs or something. And he claimed, this looks like one of those, as if you'd know what one looks like.
It's an owl, and apparently the photo is actually a couple of years old by the time El Presidente got it.
Really? He was saying 3 days or something. But yeah, he was saying the photo was old. Yeah. An owl in a tree, a shape in a tree. Some people saying it's just a shadow, etc. Some people saying what look like eyes are probably stars in the background.
It was an owl.
I'll take your word for it. It was an owl, okay, and not a luxe hanging in trees and being mischievous.
Of course, the fact that the president wanted to make some major electoral changes and he needed something to divert attention away from those and the protests associated with that had nothing to do with it.
Absolutely nothing. Nothing to do with it at all. No, just purely coincidental.
Don't look up.
Look over there. Yeah.
Here's a shiny thing to look at.
Yes.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.